Okay, so find the inverse function. So since we have this graph, we're going to go ahead and find the inverse, even though you already know to switch the table, right? If I ask you for to graph the inverse, you already know, as long as you have confidence in your table, you know it's 9, 1, 7 1/2, 2, 7, 3, 7 1/2, 4, 9, 5, and then you can go ahead and graph it. And if this is your diagonal right inverse y equal x line, when you fold it, then it's going to end up like right in here, okay? But we're going to prove that, because remember, even when you're quizzing or testing, you can have a beautiful graph, but your algebra is a whole nother step of points. You have to be able to solve it algebraically, okay? And every step has to flow. Even if you have the bottom right, it's the flow. You get graded as it flows down, okay? Okay, so we want to switch. So you're going to let y equal x, x equal y, right? So if I swap it, right? And so this is what I want to isolate. Okay, inverse operations. You're going to have 4 total. You're going to have the inverse 4 times. So what do you think the first one you can even bother to take over? Yeah, subtract the 7. So you're going to go to the k first. So -7, -7. So I get x minus 7, 0.5, y minus 3 squared. Right? So inverse operate the k. It's the constant. It's in the back. It's not tied to anything. It's not in a grouping. It doesn't have an exponent. Okay, what's the second step then? Huh? Yeah, the 0.5. So now you go for your a value. This is the coefficient to this grouping. You want to divide it out. So if you reciprocal it or divide it out, but it's going to go to both of these. Okay, so it's up to you. Do you want to write it as x over 0.5 minus 7 over 0.5? It's, you know, so when we kind of come to the end, I'll separate write it, but for now, I'll just make it as one big rational function. Okay? Okay, so then I get x minus 7, 0.5 is equal to y minus 3 squared. Okay, sometimes it'll break it up. So like for instance, yeah, okay, so here's the deal. You guys know that 0.5 is 1/2, right? Okay, so once I'm done with it, I'll take it back and I'll rewrite it. So if you want to leave it as the 0.5, you can. But remember, this is really 1/2. So if you guys were to reciprocal 1/2, it'd be 2 over 1. Yeah? And so then you would get 2x minus 14. So we'll kind of wait to the end. It's not that this is wrong, but ideally you're not supposed to have a decimal as a denominator. You're not supposed to have a fraction or decimal as a denominator. But for now, we're just cleaning it up, okay? Okay, what's the next step? The square root, yeah? Okay, so you're going to square root, right? So, right, they're inverse of each other. So I get plus or minus x minus 7, 0.5 is equal to y minus 3. And then lastly, what is it? Yeah, the positive 3. So take that over. It's a positive 3. This is your h. And so it's plus or minus, I guess I should have made that a longer one, 0.5 plus 3. It's outside of the radical, so don't, give it some space here, okay? Is equal to y, and that is your inverse function. So it's y equal plus or minus x minus 7, 0.5 denominator, plus 3. Okay, as far as the 0.5, to still have the video. It's still recording because I'm going to kind of redo this, but I'm going to make it the 1/2 because then for you, if you want to decide, oh, I don't like the decimal, I'm going to change it to a fraction and then clean it up from there. Right? Are you guys okay?
It is, huh?
Yeah? Okay, so okay, this is equivalent, yes?
Good to see it.
Right? Okay, so if you guys said the first one was K, okay, so, oh, well, hold on. We didn't switch. Okay, so you said the first was K, we took the 7 over, so you all agreed it's x minus 7, right? Okay, then you guys said take the A. Okay, in this case, A is 1/2, it's not 0.5 as a decimal, so you would reciprocal. And so what's the reciprocal of 1/2? 2 over 1, right? Okay, so it's, here, let me write it in a marker. So it's like you went 2 over 1, 2 over 1, but you have to realize it's going to multiply to every term, just like we divided by every term. So then this goes to 1, right? The whole point of a reciprocal, right, is identity property of 1. Okay, and so now you have 2 times x is 2x. 2 times -7, -14 is x minus 3, whoopsie, y, is y minus 3 squared. All right, yes, it looks different from what you guys just did. But look, if you were to grab a calculator, what is 7 divided by 0.5? Or let's do it as a fraction. What is 7 divided by 0.5? 14. There's my 14. So you're not supposed to have a decimal as a denominator, but if that's how it's presented to you, you can go ahead and go with it to the very end. But if you were to change it to a fraction, you're still going to get the correct answer. It's just, it's going to look a little different at the very end. Okay, and so then afterwards you said, okay, after the A, we're going to square root. So you square root, and I get plus or minus 2x minus 14 is equal to y minus 3. And then you agreed, go for the h. Take that h over, and so you get y is equal to plus or minus 2x minus 14 plus 3, and that is equivalent to what we have over here. They are the same thing. It's just this has a decimal denominator, which you're not really supposed to have. But if you feel that the fraction throws you off, keep it as a decimal, solve it, your algebra is perfect, but it's just at the very end, it's just, this is like, you know, kind of sad face. It's not ideal, but your algebra is on point. Okay. Here, it feels like it's too close.